You and I, we use base 10. So when you write a number, I'll make it big, 2, 5, 3, 1, 0.46. That's base 10. Notice the smallest number in base 10 is what? Talking about single digit. The smallest single digit is what? 0. And what's the largest single digit? 9. So it's always 1 less than the base. So if the base is base 10, the biggest number is 9. If the base 15, the biggest number is 14. If the base is 33, the biggest number is 32. Now, the weight of this is known as the ones. The reason we call them the ones, because the weight of that, 10 to the power of 1, which is what? 10 to the 1, which is 1, not 10. That's called the ones. The next one, we call that what? The tens? There's 0 here. Yep. And the reason this is called the tens, because 10 to the 1, which is what? 10. This is called the 100. 10 squared, which is what? 100. And this is called the 1,000. 10 to the 3rd, which is the 1,000. So that's where the name came from, the ones, the tens, the 100, the 1,000. This is called the tenth. Tenth means 110. Why is it 110? Because the weight of that to the right, 10 to the negative 1. And 10 to the negative 1 is what? 1/10. And the weight of this is 10 to the negative 2, which is 1/100th. It's the 100th, or the 100, 1 over 100. So that number, really, to find the value of that number, you go, it's 2 times its weight, 2 times 1,000, plus 5 times the weight of that digit, which is 100, plus 3 times 10, plus 1 times 1, plus 4 times 1/10, plus 6 times 100th. That's the 2,000. That's the 500, the 30, the 1, the 0.4, 0.06. And when you add them, that's 2, 5, 3, 1.46. Unfortunately, computers don't speak that language. They don't use base 10. They use base 2. So we're going to look at binary, we'll look at octal, we'll look at hexadecimal. So let's look at binary. Binary, that means base 2. Since the base is 2, the largest number is what? 1. So everything is going to be like this, 0, 1, 1, 0, 1, 0.10, something like this. And if you want to know what is the value of that number in our language, in base 10, what is that number equal to? Well, again, the weight of this one, it's 2 to the 0, which is the ones. The weight of this one is 2 to the 1, which is what? 2. The weight of this is 2 squared, which is the 4. The weight of this, 2 to the 3rd, which is 8. And the weight of this is 2 to the 4th, which is 16. The weight of this is what? 2 to the negative 1, which is what? 1/2. And the weight of this, 2 to the negative 2, which is 1/4. So that number, when you try and find out what is the equivalent in our number system, this will be 0 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1 plus 1 times a half plus 0 times 1/4. Let's do the math. What's 0 times 16? 0. What's 1 times 8? What's 1 times 4? What's 0 times 2? What's 1 times 1? What's 1 times a half? 1/2, and this is 0. 8 and 4, 12, 13, 13 and a half.
So much easier than the way that Professor Bean taught it to me in networks.
I don't know how he covered
He
it.
had like a huge chart and all
Chart,
these
yeah.
weird things. And, oh, dude,
We do everything in math.
I like this better.
It makes it easier.
Well, those guys aren't really too math centric over there. So.
So it's 13 and a half in our number system. What about for using a machine that uses base 8? Not many computers on the market uses base 8, but you could have. If you're working for the Defense Department, they try to make their own base intentionally because for security, they want to make sure when people take that thumb drive or that you use there at work, you plug into your machine, it doesn't make any sense to your machine. So they use something that's not common to a lot of people. So there's the common ones are really base 2, which is the binary, base 8, which is called octal, and that's base 8, which means the largest digit will be what? 7. So it could be 721.04. That's base 8. And I want to know what is the decimal value of that. To convert them from base 8 to base 10, again, this is octal. This the weight of that 8 to the 0, which is 1. The weight of this is 8 to the 1, which is 8. The weight of this 8 squared, 8 times 8, which is what? 64. The weight of this, 8 to the minus 1, which is what? 1/8. And the weight of this, 8 to the minus 2, which is 164. So this number would be written as 7 times the weight, which is 64, plus 2 times the weight, which is 8, plus 1 times 1, plus 0 times 1/8, plus 4 times 1 over 64. I need a calculator for this one. Clear this, quit, clear. 7 times the 64, 448, plus the 16, plus the 1, plus the 0. What's that, 1 over 16? So 448 plus 16 plus 1 plus 1 divided by 16. The decimal value that's equivalent to that is 465.0625. So this number, 721.04 in base 8, is equivalent to 465.0625 in base 10 in our number system. And the other one that we use beside binary and octal, there's one more, and that's hexadecimal. Hexadecimals base 16. So the biggest digit is 15, Well, to write 15, that's what? 2 digits. That becomes a problem. So we write the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we hit 10. Well, in place of 10, we use what? A, 11, B, 12, C, D, E, F. 10, 11, 12, 13, 14, 15. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So if I give you a number in base 16 that says, can you tell me what the decimal value? 2 E F point D4. Again, that's base 16, and I need to know what is that number in base 10. What is it equal to? Again, the weight of each one, 16 to the 0, that's a 1. 16 to the 1, 16. 16 squared, 256. 16 to the negative 1, 116. 16 to the negative 2, 1 over 256. So let's see what that number equal to in base 10. 2 times 256 plus E. E is what? 14? 14 times 16 plus F. F is what? 15? 15 times 1 plus D, which is D is 13 times 116 plus 4 times 1 over 256. 512 plus 14 times the 16, 224. 15 times 1 is 15. That's 13 over 16. And this is, what is 4 over 256 when you simplify it, 1 over 64. So let's see what that number, 512 plus 224 plus 15 plus 13 divided by 16 plus 1 divided by 64. 751.828125. So these numbers are equal to each other. This is in base 16, that's in base 10. So now we know how to convert from base 2 to base 10, base 8 to base 10, base 16 to base 10. Well, how about the reverse? How do we go from base 10? I'll take the problems backward and see if we did them right. I say, you know what? I want to convert these. I'm going to take the problem backward. Remember this problem, 13.5? And I want you to change it to binary. How do you convert 13.5 from base 10 to binary, base 2? Do the reverse. So the way we're going to do this, we're going to break it down to two problems. There's the 13 and there's the 0.5. Let's grab the 13. What is 13 divided by 2? That's 6, and what's the remainder? 1. So this is the quotient, that's the remainder. 13 divided by 2, and you divide that 6, and your remainder is 1. Then you go 6. 6 divided by 2. 3, what's the remainder? 0. What is 3 divided by 2? Because you're going to base 2, you always divide by 2. 3 divided by 2. 1, remainder is 1. And what is 1 divided by 2? You can't. 0. And what's your remainder? 1. Once you see a 0, you are done. So to read these numbers, we read them from bottom to top. And we write them in this order: 1, 1, 0, 1. 1, 1, 0, 1. Now the 0.5, we do the multiplications. You multiply that by 2. 1 point what? 0, right? So you're done. This you read down, so it's 0.1. 1, 1, 0, 1.1. You can add as many zeros at the end, just like with decimal numbers. Adding zeros on this end or on that end, it doesn't change your answer. Was that the question I gave you early? 13.5? Remember, leading and lagging zeros, it doesn't matter what base you're in. They are useless. So you can put as many zeros as you want. So if you erase that 0 and this 0, isn't that the answer we just came up with? We can do any one. Doesn't have to be just that one. Let's try another one. Convert 27.24 base 10 to binary. I'll take the 27 divided by 2, which is what? Is that 13? Yep. 13 times 2 is 26, plus the remainder of 1. Take the 13 divided by 2. 6, remainder of 1. Take the 6 divided by 2. 3, remainder of 0. Take the 3 divided by 2. 1, remainder of 1. 1 divided by 2. 0, remainder of 1. Again, once you hit a 0 here, you are done, and you read the numbers bottom to top. 1, 1, 0, 1, 1. 1, 1, 0, 1, 1. 1, 1, that's these two ones. 0, that's that. The 1, 1, that's these two. Now 0.24. Multiply it by 2. That's 0.48. So 0 plus 0.48. What's 0.48 times 2? 0 point what? 96. What's 0.96 times 2? I know the answer. 192, so it's 1 plus 0.92. What's 0.92 times 2? 1 plus 0.84. What is 0.84 times 2? 1.68.
I'm going to go over to the right just a little bit. Yeah.
What's 0.68 times 2? 1 plus 0.36. What's 0.36 times 2? 0 plus 0.72. What's 0.72 times 2? 0.44, right? And you keep going till you end up eventually with 0 here. If you don't end up with 0, that's okay. You have a maximum size register on the computer. Some machines are 8-bit machines, some are 16-bit machines, some are 32-bit machine. Once you exceed that size, it doesn't matter. So here, I write these actually top to bottom because this might never end. So 0, 0, 1, 1, 1, 1, 0, 1. That's the decimal portion of it. So these you read them this way, or you write them this way, and this you write down. Instead of this was base 2, if I want to convert these to base 8, we'll take the same example. Convert 27, not 24. 27.24, that's base 10. And I'm going to convert that to base what? 8. To base 8. We do the same thing. We take the 27, but instead of dividing by 2, we're going to divide it by what now? 8. And we take the 0.24, instead of multiplying by 2, we're going to multiply it by 8. So let's do this one first. Quotient, that's 27 divided by 8, which is what? 3. And the remainder is what? The remainder is 3. 3 divided by 8. Can you divide 3 by 8? 0. And the remainder is what? 3. And just like, where was it? Just like with whole numbers, we take the remainders and we write them which way? See this? Upward. So take these numbers and write them upward. That will be what? 33 point. Now let's look at this one. 0.24 times 8. 1 plus point what? 92. 0.92 times 8. 0.92 times 8, what was it?
7.36.
7 plus 0.36. 0.36 times 8. 2.88, right? 0.88 times 8. 7.04. 0.04 times 8. Stupid me. 0.32. We know it's 0.32. 0 plus 0.32. 0.32 times 8. And you keep going. 2.56, right? I'll stop here. But normally you keep going. So this will be 1, 7, 2, 7, 0, 2. Dot, dot, dot. There's more to come. And we'll do this one more time quickly. And I have to go. Base 10, I want to change it to base 16. So take the 27 divided by 16. That's 1 and the remainder of what? 11. Then we take the 1 divided by 16, which is what? 0, remainder of 1. Done. 1, and what's 11 in hexadecimal? Is that a B? 1B. .24 times 16. I'll do a few of them. 3.84. 3 plus 0.84. 0.84 times 16. 13 plus 0.44. 0.44 times 16. 7.04. And it keeps going. So when you write that, you write them this way. 3. And what is 13? A is 10, B is 11, C is 12, D is what? 13. So 3, D, 7. The only thing left, how do you go from 16 to 2, from 8 to 16, from 8 to 2, 2 to 16? We'll do that next time. Okay.